We just had too much grease. That's the problem. Well, we have a very entertaining speaker today. He's been a long-time friend of the board in various capacities. I don't have any pictures of it, though, Larry, unfortunately. Today we're going to hear from Larry Clark, who is the director of USDA's National Wildlife Research Center in Fort Collins, Colorado. If you've never been there, it's really quite a place. I'm sure you'd welcome visitors as long as they pay the appropriate fee.
Absolutely. Skeeter, our guard, will take care of the fees.
The tour is wonderful. They have some magnificent outdoor cages, and they're located very close to CDC Fort Collins, just across the lake, as I recall, correct? Larry has got his bachelor's degree in zoology from the University of Maryland, so he started out as a terrapin, which is appropriate.
Yeah.
But then he went to Northern Arizona University for his master's degree in biology, where he was a lumberjack. Yeah. You're a lumberjack and you're okay.
Yeah, that's right.
And then he got his doctorate at the University of Pennsylvania in biology, so he became a pacifist Quaker.
No, we're the fighting Quakers.
The fighting Quakers. Yeah. So I tried to combine terrapin, lumberjack, and Quaker and come up with one word, but you don't want to know what that is. He's authored more than 140 scientific publications, and you see his arm is in a sling. He was recently in one of our national parks, and a school bus was being attacked by 8 mountain lions, and Larry magnificently raced in, saved everybody, and had a little damage done to his shoulder. So that's why he's wounded today. Larry, it's all yours, and thank you for being here.
All right. Thank you, Stan.
I'm not going to hold the microscope, whatever that is.
Great. Well, I'm going to set this aside, and I do have a deep booming voice, so can you hear me in the back?
It might affect our video streaming, though. Let me check.
Okay. Because let's see, if in my claw hand, perhaps I can do this. Yeah, I think this might work. Okay. Well, thanks for the invitation to tell you.
You don't have to use it if you don't want to.
No, that's okay. To tell you a little bit about the center, but also some of the issues that we've worked with in the past with not only the board here, but other members of DOD. And I think you might find some of this interesting. Normally, people spend about 10 minutes or so telling about their organizations. And what I would like to do today is compress that down to a 32-second history of the NWRC. So you're going to have to read quickly. So we started out in the late 1800s. We made rat bait. We protected sheep against coyotes. Sheep were an animal looking for some place to die. Then we had food habits. It turns out coyotes eat sheep. And we expanded our mission to include more sheep. And sometimes we went overseas and protected their sheep. And we got modern and decided to work on deer towards the end of our career here. So what we have here, is the NWRC's headquarters campus is 43 acres on CSU land, Colorado State University. So the complex that we're really talking about is about like that. These are the outdoor pens where we can house a variety of animals at our headquarters. We have an indoor aviary, we have outdoor aviaries. We have a BSL-3 facility. We have classic indoor animal space, and about a laboratory office space, and then the Indiana Jones warehouse down here that has piled high with who knows decades of government stuff. So, but it's not just our headquarters campus. We actually there we are, and we have field stations scattered across the country. Logan, Utah, about 160 acres. That's where we do our predator research. Wolves, coyotes, sometimes bear, and usually these are regional. So we have glamour spots such as Starkville, Mississippi, Bismarck, North Dakota, there is Hilo, Hawaii. The red dots are field stations that were forced to close because of budget cuts. But more importantly, these are the sorts of mission areas that we have here. So essentially agriculture, resource protection, protecting agriculture or property, technology development, and that's sort of transferring that technology that we develop. We're an R&D laboratory for resolving conflicts between humans and wildlife. We do a lot with wildlife diseases, but they're programmatic diseases to the USDA, and some work on invasive species. Sometimes these topics bleed over into each other. So, I'm not going to dwell on this, but we develop lots of stuff. We have a very good analytical chemistry group. We develop pesticides. Red's for lethal stuff. Green is for non-lethal methodologies, and we go through this pipeline. We partner with tons of people. In fact, we've partnered over 64 universities last year, lots of other government agencies, NGOs, private companies, et cetera. So one of the big issues that we're really dealing with over time now is one of the things that is near and dear to my heart, and I spent a large part of my earlier career designing bird repellents, and you see now these on the commercial market. These are basically all derived from the same thing. Bird repellents, you know, keep those geese from eating the turf on your lawn, that type of thing, or on your property, I should say. It turns out that if you study the sensory biology of animals, you can learn a lot of cool stuff. And for birds, for example, methylantranolate, which is the grape knee-high flavoring, or the what makes New York State red wines non-competitive with California, it's like horseradish to a bird. They don't like it. They perceive it as pain, as you know, the types of concentrations that we're talking about. The other thing that I've worked on for a long time, and then there are other types of bird repellents that we've developed as well. I'm also a snake oil salesman. I've developed snake repellents. And so here are some of the products that are based on some of our research. They didn't give the government any royalties on this, except for snake stopper, I think. But, you know, so we've developed a lot of natural product-based snake repellents. So I'll actually go into a little bit more of that when I talk about one of our favorite topics on invasive species. There are some other cool things that we've done over the years. Right after 9/11, you know, wildlife biologists love to capture animals, and they do that by you know, using rocket nets, et cetera. Well, the problem is there are explosives involved, and it became very difficult for state game agencies to obtain these explosives after 9/11. We worked with an engineering company to come up with a pneumatic air cannon, which is actually pretty cool, and it just goes and, you know, shoots these rocket nets or, you know, out to great distance. The other thing that we worked with we adapted this actually was a military crowd control laser. Worked with the Precise Flight to develop it. Initially, it looked like a large Magnum flashlight, but they thought it'd be cooler if it looks like a pistol. Nothing better than walking around a park in the urban environment at night with something like this to sort of. And the bottom line here is that it turns out that red laser light creeps out a lot of birds. So you can have fun. You can take your laser pointer out to the park tonight, and if you find some ducks or geese, you can actually walk them across the habitat by just, you know, doing that. And it's not quite as fun as, you know, kind of dotting your cat, but it'll, you know, birds aren't quite as nimble along those lines, but they'll waddle away and they'll be afraid of this light. When we do our Group's roundups in urban areas, what we do is we use the laser to drive them in from side to side, and then we use the little motorized speedboats when they go out in the lake to drive them back in, and then they go into little funnel traps, and we reduce the urban populations that way. Excess geese go to the abattoir and into the food pantries. We have things like, sometimes we do the deceptively simple, like scarecrows. So this is scary, man. You see them at, you know, you see them now at places like, you know, used car lots. And we have a second generation that's much more effective, and we're a very clever research organization. We call it Very Scary Man. So we do birth control for wildlife. We have wildlife for pigeons and geese and deer. Contraceptives for pigeons, geese, and deer. And, you know, so we've developed that for urban environments to help reduce the population, because it turns out that, you know, Canada geese and pigeons, everybody likes wildlife, you know, but it's like prunes. Is one not enough, three too many? And so we really try to get a handle on regulating the overabundance of wildlife when they become nuisance or cause damage or interfere with other sorts of activities, but not necessarily punish them. And then the next slide I'm going to show you is we worked with this company called Brooks Manufacturing, and it was really with Southern California Gas and Light. And in this case, this is a pileated woodpecker, and wooden power beams. So it turns out woodpeckers can just destroy these things. In 24 hours, for example, on that beam, a single woodpecker can peck away and essentially go through that entire beam in 24 hours. They do it for courtship, looking for food, drumming behavior, and so I'll just show you in this particular case. You'll see the little wood chips flying off. This is what woodpeckers do. I chose this one because it looks like Woody the Woodpecker. Okay. And then this is a polymer coating. Basically, it's like tough bed, truck coating, except it's a little bit more elastic. Well, you can see little dimples in this. Their heads bounce off of it. They really don't like it.
But they keep trying?
They keep trying, but it's pretty resilient stuff. So it's a very... They're not smart. But, so for example, this coating material is easy to apply in a variety of situations. So, for example, flashing on your chimney when the flicker comes there in the springtime and starts whacking away and wakes you up early in the morning, or coating power poles. You never see a lot of woodpeckers trying to attack the beds of pickup trucks, and this is probably the reason why. Anyway, the bottom line is that they just can't penetrate this. And it's a relatively cheap, it's not our invention, we just had a different application for that. And this is just a list of stuff that we often try to transfer our technologies to the private sector, so that enables American business and all those sorts of things. But we maintain registrations in the USDA, or APHIS certainly, and my research group is essentially the one responsible for generating the labels and maintaining the data through the EPA or sometimes the FDA registration, or if it's another type of a system through veterinary biologics. So we do it all, and we have a pretty good analytical chemistry and quality assurance program as well. Now I'm going to talk, so that's organizational, what we do, but now I'm going to tell you a series of stories of sorts of things that we do at the NWRC. And everybody, and we have our National Aviation Coordinator here, Mike Beezer. Mike, raise your hand if people don't know you. Mike oversees and coordinates a lot of our activities with respect both the operational side and collaborates with us on the research side. But I think what most people will recognize, this is an animation of what happened on the Hudson. And this happens a lot in terms of collisions.
Check this 15.9 report to the contact line, maintain 15,000.
Maintain 15,000, cactus 1549.
This is an animation, of course.
Cactus 15.9, turn left lane 270.
This is Cactus 1539, hit birds to cross thrust up it's returning back towards LaGuardia.
Okay, you need to return to LaGuardia. Turn left heading up 220.
220.
Sorry, stop your departure. It's got emergency returning. It's 1529. He bird strike. He lost all engine. He lost the thrust in the engines. He's returning immediately.
Cactus 1529, which engines?
He lost thrust in both engines, he said.
Got it.
Cactus 1529. We can get it to you. Do you want to try to land 1313?
We're unable. We may end up in the Hudson.
Hi, Cactus 15.9. It's going to be left traffic to runway 31.
Unable.
Okay, what do you need to land? Do you want to try to go to Teterboro?
Yes.
Teterboro, Empire, actually, LaGuardia departs guy, emergency inbound.
Hey, guys.
Cactus 1529 over the George Washington Bridge, wants to go to the airport right now.
What's going on, airport? Check. Does he need assistance?
Yes, it was a bird strike. Can I get him in for runway 1?
Runway 1, that's good.
Cactus 1529, turn right 280, you can land runway 1 at Teterboro.
We can't do it.
Okay, which runway would you like at Teterboro?
We're going to be in the Hudson.
I'm sorry, say again, Cactus? Cactus 15.9, radar con.
So it was fortunate that no lives were lost at that point. But this probably most dramatically illustrates problems. Certainly the military has experienced some tragic bird-aircraft collision issues. And so we have devoted a lot of time to develop research and development in this area. How do you get birds to avoid aircraft? Now, right after this, there was a lot of hype about these portable radar systems, adaptive technologies, et cetera. All they are, potentially, are forecast systems. And a lot of them are not validated, and there's a lot of use. And so what we're engaged with now in terms of collaboration with the National Center for Atmospheric Research is validating, essentially how these systems work, and what can they be used for realistically in terms of forecasting. It's the NCAR, of course, are the guys that develop a lot of the software for the wind shear prediction. And so we're looking at those sorts of things. But more proactively, we're looking at a lot of other areas. We study the sensory biology of animals a lot. And in this particular case, we're looking at lighting systems that we might be able to place on board, which are passive, that would just be part of the airplane that wouldn't interfere with other sorts of operations. And it turns out, and what we think we're being able to exploit here, is if you need to alert a bird earlier, because through carcass analysis, what we're finding, and you pick up dead birds that get hit on takeoff or landing, and a lot of the bruises are on the back sides of these animals. They're trying to get away. They just can't fly fast enough. And so what we're really trying to do here is find out, okay, can we alert them earlier? And in essence, and now you're getting in sort of the cognitive abilities and sort of the perceptual abilities of birds. What you want is early alerting, and you want to give the appearance of an object looming very rapidly, perhaps more so than it really is, and then elicit an anti-predatory response, in other words, escape by the bird. And we started out by looking at different pulse frequencies and wavelengths, et cetera. And at our Plumbo Field Station in Sandusky, Ohio, we are able to, and we're on a NASA site. It's about 6,000 acres. They used to test solid fuel jet engines for NASA there, so there's a large blast zone, and they allowed us to occupy that. And so what they do is they have these long straight roads, and we drive trucks at really, really high speed towards birds in a cage at the end of the road. It's a lot of fun. And, you know, we have different sort of light configurations on them. And you look basically at what the reaction times are. We're becoming more sophisticated, but the bottom line is that we think we're honing in on transportation relevant lighting systems that will alert different types of animals earlier so that they go through this escape behavior. Other things that we're looking at right now, we just had a press release that came out on this, is, you know, of course, we want at airports no wildlife. And there's a conflict between land use patterns here. But you don't want to have an airport that attracts wildlife that would get into the way of aircraft. And so we're looking for things that are hostile to wildlife. This is the one place you don't want them. Vegetation type of structures or other land use patterns, solar energy, wind energy, or biofuels. So, for example, general aviation airports might be able to generate some revenue that way. So we're looking at those sorts of things, and this could actually be quite useful for the conflict between humans and wildlife. I mentioned a little bit about the collisions. The same sort of lighting systems that we're applying to birds can also be applied to mammals like deer. And so here's a police cruiser, and it's obviously had an encounter with something. Like cops. Got a little dashboard cam going on here. Police cruisers going down the road. And some of you may have experienced this yourself at times. We don't need to go through it again. But the bottom line is that the same lighting systems, different wavelengths, different pulse frequencies, again, to alert the deer and actually get them to run in other ways as opposed to in front or across the path. And those are the sorts of things. It turns out deer whistles don't work, by the way. But this might actually have some potential. And over $1 billion a year are lost annually in automobile collisions with wildlife such as deer in terms of insurance claims. Okay, invasive species. This is an area, this was a study done by Pimentel at Cornell, and these are his estimates. And you know, even if they're loose estimates, the order of magnitude in terms of the error are pretty large. Losses due to rats, feral cats, livestock diseases, pigeons, starlings, feral swine, feral dogs, mongoose, and feral horses. In terms of habitat degradation, actual physical damage, disease, you name it, it's pretty substantial. So we take invasive species pretty seriously. And we look at a variety of things. Now, here's an example. And this is actually, I think, in Frederick, Maryland. And this is a car wash. The guy at the car wash was losing money. And he was going to catch the burglar. So he was casing his own car wash, and he was taking pictures. And here's a starling. Here's the coin box. Okay. See if I can get this to advance. There's a starling going into the coin box. There's a starling of a quarter. And he's escalating his damage. 3/4. This guy lost, purportedly, $4,000. All this male starling was trying to do was clear out a cavity so that he could raise a family. But this is just an example. I mean, it's obviously a very direct sort of monetization of damage by wildlife. Now, I don't know what they use the money for. The starlings maybe build a bigger nest box. I'm not really sure. But improve the nest box. But the bottom line is that it wasn't a thief. It was the starling. And they were just going up into his coin machine. But this is, whether it's direct damage like that or more traditional, and this is one of my is the poster child for wildlife services. This is the brown tree snake. Now, many of you have been to Guam, or some of you have been to Guam at least. This is a rear fang venomous constrictor snake that got on to Guam shortly after World War II, and has caused great havoc. Of course, for those of you who haven't been to Guam, it's there under the typhoon, and it usually is. I don't know if this is true, but I heard somebody claim once that Guam was always within 48 hours of some sort of tropical storm. And over a 7-year period, I spent about a year and a half on Guam various times, and I kind of believe it. It's really interesting the first 2 times you go. Second, third, 20th, not so interesting. So that's where Guam is. Where did the snakes come from? Well, either the north coast of Australia or Papua New Guinea. We're not really quite sure. But it was actually a single introduction. Genetic analysis suggested it was a very restricted population. So it came from many snakes from a very small locale, or one snake that eventually populated the island, rabbit snake, obviously. And so the idea behind this is that there's been a lot of surface traffic across the Pacific over the years. What happened on Guam? Why did the snakes take over, and what did they do? And so here are some interesting, sizes of snakes, right? Now, I do have to ask you, what Kodak moment of the parents? Oh, look, dear, there's a snake in our child's bed. Quick, get the camera. But, what are the issues that these snakes cause? Like, they can get up to a fairly large size, 10 to 15 feet. The density estimate is pretty accurate. It's probably a little bit lower now because of control efforts, but it's pretty high. Attacks on infants. They're a rear fang venomous snake, so it's not like they have fangs up front, puncturing to deliver a lot of venom. But give them a chance. They'll chew on you for a long time, and that venom will come in to your system. So 50 infants a year or so go into anaphylaxis and have to go to the hospital because of things like this that are happening to get into the house. They turn up in unexpected places. Apparently there was a Commonwealth legislator that sat down on the toilet and one bit him on the balls. Attacks on dogs, cats, and poultry, and, of course, power outages. So those are the sorts of things that can go bad. And from an ecological perspective, they like to eat rats mostly, but the birds kind of got in the way once the populations got large. And these are just animals that have disappeared. Native birds driven to extinction. Native birds still in the wild but uncommon. The Mariana crow, there's one left. It's a male. We don't think it's going to recover that population. Of course, there's the island of Rhoda, and, kind of next door, where they do exist. And then non-endemic birds that went extinct. And then all sorts of other things, lizards that are rare, thriving, and gone by the wayside. Okay. The cool thing that we did, and this is actually was funded through the Legacy program in our collaboration with DOD, was we looked at getting detector dogs into the system. So, the dogs sniff the cargo, they identify a snake in there. Of course, sometimes the snakes bolt, they don't go very far. Or we might, the dog will indicate that there is a snake in there, but we don't know if it's still there. We developed things like cargo fumigants, so you can fumigate cargo coming in and out. We're still working on attractants, since the snakes do like rodents. We're trying to get basically the sort of the perfume of the Eau de dead mouse. Snakes actually like that quite a bit. And that will come into play. We've developed toxicants. A toxicant for a brown tree snake, a good one, is acetaminophen. We do have that registered with the EPA, Tylenol. It turns out that Tylenol doesn't like me saying Tylenol, so I won't say Tylenol anymore. No one in the U.S. would sell us acetaminophen because they didn't want that product to be associated with killing things from a marketing point of view. So we bought our acetaminophen from China. We have traps where we have live mice with their little water source, which is the potato, and then the bait block. Snakes go in there, and they can't get out. It's a minnow trap, essentially. But we're trying to develop artificial lures so we can basically not become mouse ranchers. We're very good at mouse ranching. We don't want to be in that business. We want to capture snakes. But more importantly, in remote areas and for cost efficiencies, aerial delivery is important. So combining our dead mouse with parachutes that are biodegradable. We spent a long time investigating biodegradable dead mice and parachutes, lacing them with acetaminophen, And kindly, with the support of Anderson Air Force Base and HC-5 in the early days, we had airmen sitting at the back there just throwing dead mouse and parachutes out over the landscape. But the cool thing about that, I'm sorry, and here's, we've developed repellents as well. Remember my comment about snake oil? And so there's a snake resting inside the tube there, snoozing away like snakes are apt to do. Remember, the dog might be able to find the snake, but do we know there's really snakes still in the cargo? Oops. And hopefully, there we go. So you give it a little spray, 2 shots, snake comes bolting out, goes up your pant legs if it weren't in a cage. Quite effective. It turns out things like cinnamaldehyde are a great irritant for snakes, so you can go into the grocery store and buy cinnamon stick glade, you'll do the same thing. Okay. So, getting back to our toxicant, this was on the munitions storage area, but more importantly, these are the control plots where we were indexing, the number of snakes that were still taking baits there, and these are the plots, the red, that basically had the acetaminophen, and after a very short period of time, you get to a base population. So you can suppress the population of snakes in restricted areas quite effectively using this methodology. All right, other invasive species, things like coqui frog. This guy is probably about as big as your thumb, came from Puerto Rico, got onto the island of Hawaii, and each individual male frog has a courtship song that's about 120 decibels loud. It's like a rock concert. In Hawaii, often you can't sell your property unless you're, or at least at the value you want it, unless you're declared coqui frog free. So this is a big deal. But ecologically, they eat native insects. That changes the leaf litter composition, changes forest structure, changes bird community, etc. So this is an invasive species that not only is just a nuisance everywhere, of course, other frogs in the world are dying because of chytrid fungus. Here's one that's become a plague, and it can influence both economics and ecosystems. Okay, Florida. Now, I'm just going to whiz through a whole bunch of slides here about Florida. The only thing I have to say is put a fence around Gainesville, charge admission. We got all sorts of things in Florida, and we're working on some of them, but it is a mess. Burpee's python, here are some locations. You can see the incidence rate of discoveries. Nature is trying to control it. Here's an alligator that tried to eat a Burmese python and exploded, literally. There's the alligator, and there's the python. I don't know which is which. There's the legs of the alligator.
How big was that python?
About 12 feet. So, and it was, obviously very, very thick. So, I mean, that's kind of a glamorous case. But more importantly, it's not just pythons. We got green anacondas. We got Indian rock pythons. We got other sorts of pythons I don't know the names of, but they're all out there. And other invasive species, like the tegu, Nile monitor, and a plague of frogs. And all of these guys are out there. They shouldn't be there. They're actually altering the ecosystem structure. And so, we have some real problems. Other sorts of things. We had nutria introduced in the United States many, many years ago. And the primary reason that nutria were introduced because it was the fur trade. We wanted to have fur coats. Well, it turns out that got out of vogue. Nutria escaped, and here's where they are in the United States now. So what's the problem with nutria? Well, the problem with nutria is they denude marshes. And if you're along the coast, such as in Louisiana, that has a lot to do with storm surge protection. And if you have an animal that's eating the marsh, you need to control. So, for example, here's minor damage, but you can see just with your naked eye of what goes on in these marsh situations. Here's more dramatic nutria damage, and it's significant. That open water used to be marsh. So here's Blackwater, a local refuge here in Maryland, 1938, 1974, 1989. Just the loss of marsh. So we haven't solved the problem just yet, but we're looking for other markets. Now, actually, we have trapping programs operationally, and they've done great good in terms of marsh restoration by basically depopulating the marshes of nutria. What we're working on at the research center is basically better baiting systems and attractant systems for these animals.
Is there any place where they catch them and eat them?
well, you know, it goes without saying, Louisiana. But I'm sure some of our operational guys do too, but some of them may be from Louisiana. Okay. The typhoid barrier, or the new poster child for wildlife services, besides brown tree snakes, is feral swine. In 1982, this was essentially the range of feral swine. In 2004, this was the populated range. They're actually in all 50 states to some degree or other. They carry 30 known zoonotic and agricultural diseases. They cause habitat damage. They're predators on sheep. Remember sheep. So they are very bad. And we're working with the Australians, co-developing a toxicant for registration, sodium nitrite. It will meet some humane standards. It's relatively quick. Right now we're working on exclusive delivery systems because it'll kill all animals that eat it. And what we're worried right now in some areas, are bears. Because anything that you can design that that'll keep most wildlife out, but that a pig can get in, a bear can get in too. And so we're working on those issues. Okay, so, for example, I'm going to segue into some disease issues, but feral swine will pop up here. This was the E. coli outbreak in California that happened. So you get cows, they have a pathogenic E. coli to humans, but not themselves. They are near the water, they leave their cow pies. Feral swine come pick it up, they do feral swine stuff, and they do that feral swine stuff in lettuce fields or spinach fields. And that was because we process these in processing sheds, and that product gets shipped across the country. There's where it went during that outbreak. And do we know where it had come from? Well, genetic analysis suggests that we can trace it all the way back there. And the sorts of things that we're dealing with now, of course, it has huge economic damage. What we're trying to deal with right now is if you have, if you've ever been to the Imperial, Coachella, Sacramento Valleys of California, places like that, you just can't put a fence around these places and keep stuff out. So what do we do actually to mitigate against the potential disease risk along these areas? And we're working on strategies for better sampling, so when you do get contamination, you can essentially have zone-off areas that are at higher risk and allow the harvest of the rest of the area. This will have to be a policy-level decision at some point, but those are the sorts of things that we're trying to work on. I want to tell you a little bit of a story about how this gets into when you have large areas and how you're trying to protect them. Avian influenza, 2006, this became a big deal. It's still a big deal worldwide in terms of chicken disease, but it got a lot of attention. Well, here is the surface traffic of the world, commercial surface traffic. As you can see, you're pretty much within about 4 or 5 days, certainly 1 or 2 days along the coast, of anywhere in the world. That's important in terms of human populations. Stuff can get around the world pretty darn quickly nowadays. Here are the migratory flight paths for birds, and people were worried that birds would be carrying this all over the place. Of course, they draw nice, really discrete lines for that. Okay, so here's what our dilemma was. Wildlife biologists really like to capture animals and wrestle with them and do stuff like that. And as a research center, because we're a feat, we're not necessarily concerned with that. So we asked the question, do we really need to touch those ducks? And, so the answer generally is, well, maybe not. Maybe in avian influenza, it's a fecal environmental contamination. Maybe just go to the water and sample it. So we devised methods. You can drive your truck up, we're also lazy, to the edge of the water, put a pump in there, pump the water, put it on a filter, analyze it for the virus you're looking for, and do it cheaply. So we developed that. So now we've answered the question, now we don't have to touch ducks. But where do those ducks go? So we went to the data that Fish and Wildlife collects, and we kind of asked the question, we're looking for a disease that's probably going to be close to zero prevalence on a continent. Where do we look? How do we do it cheaply? The money's going to run out eventually. So we looked at banding data. We found out in the winter and early spring, these are the locations, big dots mean lots of ducks. These are the places you have to be. Later in the year, it kind of diffuses. We're not going to worry about that graph. But if you ask the question, I want to capture or see 95% of the North American waterfowl, ducks, geese, swans, how few places do I need to be? Well, there you go. That's where you need to be, sometime during the year. So now we can say, we don't need to be everywhere. We just need to be at those places, and I can drive my truck to it. Sample the water. So where are the populations? We answered that question. Where did they come from? Well, they come from Canada. Darn Canadians. And then where are they likely to go? How few places do we need to monitor? We've answered that. And where do we put our detection network? Okay, remember, we had, these are the cool migratory flyways for birds. Very discreet. Easy, right? No, not really. let's say you captured a duck there. Where's it likely to go? From banding records, that's where it's likely to go. You get the sort of fantail out. So you get our modelers involved, and basically if we captured a duck at that location, red being the high likelihood of where it's likely to go downstream, those are the locations that you need to now sample. And the other dots are cooler colors, mean it's less probable. So now we can say from whence they came, where are they likely to go, and we're not going to be controlling North American ducks if we do find a highly pathogenic H5N1. So from an agricultural point of view, we can do the same sort of maps of broiler operations, turkey operations, et cetera, and those are where we're going to concentrate our efforts, how that overlies that. And now we're getting to something economical. Okay, so what? Now we can predict where the problem's going to be and notify the farmer that he's hosed. Okay, so what do we do now? Well, we again engage some of our wildlife biologists and our farmer and our modeler guys, and this is what a farm kind of looks like in a cartoon sense. You do network modeling, and that's what that box diagram looks like in probabilistic terms, in terms of pathways. And what we're looking for, there's a thin blue line right there. So the question you have to ask is that something now I can control and break the disease cycle? Those are the sorts of things that we're looking for and what we can manage. And maybe that thin blue line might be that line, or it might be some other line. The question is, now we've identified it to a scale which we can actually economically manage. And those are the sorts of things that we're working on right now. So we have collected, we collected hundreds of thousands of samples, both environmental and direct swabs from animals. So we had all these avian influenza matrix positive samples sitting in our freezer, and I'm stuck in traffic on another lecture tour in Philadelphia, stuck in the Schuylkill Expressway, and I hear on NPR about the outbreak in Mexico of H1N1. And I called our laboratories. I said, how quickly can we sequence those genes? Because is our wild birds a problem? And the cool thing about, each of these studies that we do gets to a new phase. These are basically hematogluten and the neuraminidase genes. The important here is what the CDC characterized as the human outbreak, so that would be that portion right there and that portion right there on the other gene. Wild bird samples from our USDA samples are over here and over here. Short answer, after 3 days, don't look at wild birds, don't waste your money. So it's kind of cool. We were able to save a lot of effort along those, and we looked, other people looked elsewhere. Okay, applying those same principles, we got rabies. And there are lots of strains of rabies in the United States. And we're collaborating with a whole bunch of people, the CDC, Marielle Pharmaceutical Company. Raccoon strain rabies in the East Coast is what we're worried about. It used to be constrained in the Southeast. Coon hunters brought them up north. Now you got it in spades all over the place. And in essence, what we don't want is mixing of strains of rabies. So what we have here is a few raccoons into the infinite distance on a Florida highway, by the way. I don't know where they were going, probably north. And what we have down here in this little tiny map is the incidence of animal rabies cases, raccoon strain rabies. So we have developed, so here are our challenges. We have a fixed budget. Everybody has a fixed budget. Stuff on a continental scale. We have eradication as a goal. And we got to prevent the mixing of wildlife strains. No small feat. So we have in blue here our Maginot Line, where we drop rabies vaccines from airplanes. We carpet bombed the United States on a 40-mile swatch from Canada to the Gulf of Mexico, using natural barriers in some places. And then we do surveillance around that area. So we drop about 10 to 12 million baits a year. Around cities where we're likely to mock people, we kind of hand place them. But the idea is you're creating a vaccination barrier. Sometimes we get breakthrough, like around Cleveland. Now, there are many reasons that you might get a breakthrough around Cleveland, but one of the reasons is that our vaccine is actually an orthopox virus-based vaccine, and it turns out there was a natural wildlife disease, orthopox, circulating out there. So the animals were pre-vaccinated against our vaccine, which is kind of cool. Then you develop strategies. But here's our problem, okay? We need to make this more cost-effective. So again, our challenges, fixed budgets, cost of baits, cost of fuel, cost of people, and we want to optimize the spatial placement of baits. So how do we do that? Well, we can give up. We can eliminate the program. Some members of Congress have suggested that. We can maintain our status quo forever, not very satisfactory, so we have our Maginot Line, and somebody's going to break through eventually. Or we can solve the problem and eradicate it, like Sherman, march it to the sea. Okay, so we've done some simulations to address the congressional interest in eliminating the program. And here are some simulations. We have a whole bunch of these sorts of simulations. These are 2-year intervals. That's 20 years out. This is where we think the disease would be after about 20 years. And, we did some economic analysis. What are the consequences in terms of animal prophylaxis, veterinary costs, et cetera, along those lines? And the idea is that if we did nothing, it would cost a lot of money. If we establish actually an ORV zone for elimination and drive it to the sea, we think it would cost us about $58 to $148 million. If we didn't do it, that's what the cost would be. And so here's one of many plans about moving it seaward, as it were, after many years. But we have a fixed budget, so we're in a static holding pattern right here. So we're looking for different ways in which we can optimize our program in terms of spatial, reduce fuel costs, reduce personnel costs. And so benefit of our war efforts and our drone technology, we're working with a variety of government agencies. Here's a Raven. The idea is that to increase payloads, drop baits from these sorts of things that can fly on transects, so we're going to be reducing fuel costs, personnel costs, et cetera. Develop better delivery technologies that can be easily mounted on these systems, basically paintball technology. You can put anything in a paintball. You can make baits out of paintballs. They can be at different hardnesses, different release patterns. You can put all sorts of things in there, and we're almost there. And then, of course, we have infrared thermography, where we actually can surveil large areas and identify basically animals that are healthy and animals that are infected using visual systems like that. And essentially, what we're doing this, and you can apply this to FMD, rabies, or whatever. Those are the areas that we're working on. So kind of the issue here is if you only have one tool. Oh, by the way, that's a DC-10 at JFK. Probably was that 68, 72, Mike? In that time frame. Yeah, no one actually died. That was a training flight, but it hit basically 4 laughing gulls, and it came down. So, and I want to finish off is that our solutions, what we're aiming for at the NWRC, are simple and elegant solutions. Now, pay attention here. It doesn't have to cost a lot. It just has to be effective to get the job done. So, on that note, I am going to leave it. Thank you.
Wonderful. We'll take a few questions.
Absolutely. So,
we've got time for a few quick questions. I'm sure there must be some.
Sure.
What's the status of good old-fashioned rodent control in the United States? Are we on top of the problem, or are we facing a...
Yeah, I took those slides off because there are way too many slides to begin with here. The question was, what's the status of rodent control technology in the United States? It's poor in terms of new product. We're concerned that somewhere on the time horizon, maybe 15 years out, 10, whatever, we're probably going to lose some of our registered pesticides, anticoagulants, and zinc phosphide. Uses are being restricted. I have a toxicologist on staff looking at different systems where, for example, we've identified some adjuvants in pomegranate juice and grapefruit juice that you can add to existing anticoagulants that make them 100-fold more effective, thereby putting out 100-fold less. And so we're working on those sorts of things. That's a delaying tactic. What we're looking at are other sorts of rodenticides development. So
We've got 23 people video streaming, and we have a question from a video streamer.
Okay.
Here. It says, what did you do to your arm? No, it says, did you do any work with the rabies case last year?
No, we did not.
There you go, Mark.
Sir, just an editorial compliment. One of the most informative, best presentations I've seen in 10 years here at the seminars.
Well, thank you.
Really good job.
Well, thank you. That was, for those of you who didn't hear it, he was asking me how I broke my arm.
Are those oral rabies vaccines available to communities and for, say if a community wanted to treat an area or something like that, or just in your program?
The question was, are the rabies vaccines that we use in our operational program available to communities and under government use and control? Okay, is the answer to that. So primarily our operational program does the rabies vaccination program, but I believe there are some other governmental organizations that do participate. Certainly, for example, state health programs. In Texas, for example, were instrumental, more so than we were in Texas. Yeah.
And that next to the last slide you showed,
Yes.
the power lines and that looked like maybe there were some electric things up there.
And that was a monk parakeet nest. The power line, yeah,
It's like a condominium.
it is. It's a monk parakeat condominium. So the question was, I showed a slide in the next last slide that showed a large bunch of sticks up in a power transformer utility pole, and that was a colonial monk parakeet nest. We actually have a contraceptive for monk parakeets. They're pretty. People don't like to kill them, and so you phase them out, as it were. That's a big issue. It turns out there are other issues. We worked with NASA on their space shuttle when it was flying about vultures hitting the space shuttle once in the news several years ago, knocked off some tiles. On microwave towers, lots of vultures defecate. It's a hazard to employees that are trying to clean those towers. It turns out that the solution was relatively simple. We designed a scarecrow, an effigy. We worked with, Disney World and animatronics. None of that stuff worked, so we bought basically what looks like a buzzard from China. Again, it's basically turkey feathers, and all you have to do is have one crooked wing, and if you turn it upside down, and if you do it at night at the vulture roost, it scares the bejesus out of them, and these vultures go away. However, they'll come back during the day and eat it. So they won't sleep with their dead, but they'll eat them during the day. I'm sorry, there was a question in the back.
I was just going to ask about follow up with the rabies question. It seems there's a lot of ORV programs for terrestrial carnivores. Are you doing anything with bats or?
The question is, are we doing anything with bats and other animals? We do carnivores in terms of canine, fox, strain rabies, et cetera, down in the Southwest. Bats are intractable right now to us.
White nose taking care of it.
Yeah, we've been approached on the white nose issue. It could impinge upon agriculture, our mission area. We view that as a USGS interior issue at that point. I mean, I know we're begging off on the issue, but we can't do everything.
White-tailed deer on the East Coast,
Yes.
What's the solution?
Okay. We have actually developed an immunocontraceptive for the white-tailed deer on the East Coast. What's the solution? So, for overpopulation. We have developed, at the request of actually the state game agencies in the early 90s, to develop a contraceptive. And we, 15 years later, we actually succeeded. They didn't think we would. And the important part of it was a single-shot vaccine. So with wildlife, you don't get a lot of chances to see them again, or the same animal, often. And so we developed a single-shot immunocontraceptive vaccine. We make the animal basically autoimmune to its own reproductive hormones. Okay? And it's fairly effective. It's not, it's a little bit leaky. There's vaccine breakthrough, that type of thing. But it's pretty good. So we have developed that. The state game agencies then came after us because we have attacked their game animals, and it's a revenue generator for states. It was very controversial. We took a lot of heat for that. Maryland, and so we registered it nonetheless. We spent all this government money, so we registered it at the federal level. So there's a federal registration for an immunocontraceptive for white-tailed deer, females. It works actually against any mammal. Okay, we're the only laboratory in the world that makes it. Okay, so you have to get it through us. It's a federal label, but 2 states have actually come in to register it, Maryland and New Jersey. And that's kind of the states we were targeting, large urbanized states. The idea is that you have a urban population of deer in a relatively constrained island habitat, like parks, where there's low rates of immigration and emigration, and you cull them using other methods, lethal control, but then you slow the population recovery rate using contraception. That's our suggestion.
How widely is that currently being used?
It's being used in those 2 states in local communities right now. So you could just call your state DNR, and they could tell you about it. Or you could call our operational state directors in those 2 states as well. Any other questions?
A representative from the Canadian Defense Forces is here, by the way, and we've immediately started to try to repatch a relationship with them.
Yeah, I try. My wife warns me, but I always step into something.
Okay, anything else? Thank you very much, Larry.